Hi, Sportster Paul here with our third impression of SolidCAM, CAM program, computer-aided manufacturing, makes G-codes for your milling machine or lathe. We're past the more exasperating part, setting up the part, doing things like that where I had some problems. Now we're in the love part. We're making toolpaths. We got 3 of them knocked out last show. Now I'm going to show you a toolpath that nobody else could do. Well, you can do it, but with sketches and little kludges. You can do it with SolidCAM right in the program geometry selection. So that was a cool thing, something to love. All right, let's get up here and look at SolidWorks. Here's always a little exasperation. This is the trick. You go, let's see, File, Open. So this is the part the way it was where we left it last show. That's why it's got a -2. Second episode, we're doing the third episode. So you say open this, and it opens the part, and then it asks here. Now it wants to open the CAM part. Now I want to make a copy of this, call it -3, and then post both of them on the website that I'll put down in the description. If you open it here, that kind of locks up the file into the SolidCAM software program running. And then if you try to do a copy as or a save as, it'll fail because SolidCAM's saying, well, I got this and I don't want to let go. So it's not going to let SolidWorks grab that part of the file and copy it over. You get something like model failed or model copy failed. So the secret is, if you want to do like I do, make another file, you cancel here. You don't open the SolidCAM version of what's inside this solid part. You say cancel. Now you can go your normal file, save as, excuse me, save as a copy. This one is going to be -3. Simple as that. Say, save as a copy and open. I'm doing save. Does its thing. Now it's going to ask us again. Now this is to open the new part, the -3 part, right? It's not clear, but yeah, it's okay to open this one. Go right ahead. You open it. Here it comes. Sometimes it's been prompting me. See, this is the tab for SolidCAM, and it's got all those features that we did last show. What's interesting is sometimes it prompts me, do I want to close the original file or not? Sometimes it doesn't, so it didn't. So we go here, this is the original file, and you can just go close. And because you didn't have that CAM part open, with that CAM part open, if you just open it, accept the CAM part, and close it, it'll update the file date. Might screw up your configuration management. It's like, why has this file got a new date? I just looked at it, right? So I don't know what you'd do if you wanted to look at the CAM data and not really do anything. I guess go in the task manager and kill the process. That'd be the only way to keep it from writing to the file. But it's a minor wrinkle. I don't know if you can close. That'll be another thing for me to do. Look and see if I can close. See, I think if you just close that CAM part, it's also going to write to the file, no matter what. And this is maybe why I have this whole external business, where if you don't want to save the toolpaths inside your solid part file, you can save them as an external file, which is a zip file where they copy your original solid part, add a couple of things, throw all their toolpaths into that zip file, and then link them. So if you change that solid part, the original solid part that you're working on, which is now clean, doesn't have any toolpaths, nothing, small as it can be. If you go and change that, next time you open the CAM part, the PRZ file, Z for zip, then it'll prompt you to say, hey, the original file you made this thing from has changed. Do you want to update to that? And then it's pretty clever about, well, the stock's changed. This, it kind of highlights what you're going to have to go examine. I like that. It's a little more manual. It just doesn't go roaring through saying, oh, we're going to make new toolpaths based on what we think would be the new modified geometry. So that part I kind of like. But you got to get over this, what's it copying, what's it not. As always, I like to come up here. You got to hover a little bit and wait. It's very exasperating. -3. This is the part. It's not just CAM programs. It's SolidWorks, making sure what you're working on and is it up to date. So now we've got, I can show you. See, it also, like MasterCAM, keeps moving the tree over. That's, I guess if you made it this wide, it would stop this. The scroll bar goes, well, MasterCAM doesn't give you a scroll bar. You got to use the Logitech mouse with the rocking or do this, open it up wide enough and then go back down narrow. And it's just these long strings here that do that. If you could label things shorter, it would work. The stock, it's always good to check the stock. Yeah, that's kind of where we expect the stock to be. That's up here. Why they create this updated stock concept, I don't know. Here, this will light up all the, this is similar to SolidCAM, little check boxes. There's all the toolpaths we did last show. And then any individual one, you can select multiples, unselect. So here we are, we've got it as far as the shallow pocket. So we got the outside of the part, we got it decked, we got the outside of the part, we got the deep part of the pocket down to this little plateau, and then we got the shallow pocket, as I call it, going the rest of the way down, and it's happy. So what's next? Doing this flat area. Now there are ways to do, like I want to do 3D roughing. Just go and carve everything away from this model. It'll take an hour, and then I'll do finishes. I want to do all the programs we're evaluating, which is everything that works inside SolidWorks, other than Hypermill, which doesn't think I'm good enough to play with it. They said you're a novice user. We don't want you making YouTube videos. Okay, I won't. But SolidWorks CAM by CAMWorks, Bobcat CAM, Visual Mill, MasterCam, and SolidCAM. These are the gold partners. There's a couple other gold partners. You can go on SolidWorks website that work inside SolidWorks. Those were more specialty. One was like a tool and die specialty. Another was for show displays, at convention centers. So we're not going to do those. So here we are. We want to do this flat. This is what you're going to love, right? This is deep love. You go right click, add a milling operation, and this is going to be a profile. Takes a while. It gives you the mystery boxes. Oh, you have to learn. That's what you want. It's a new geometry. It's got enable chain direction, so that caused some problems, but we kind of understand what all of this is down here. Here's the cool thing. You go down a little further, and you say point to point. Now, in the other programs, you had to make a sketch. Some of them I didn't know what I was doing and did goofy sketches, a big rectangle here, and treated it like a pocket. My friend Dave was a MasterCam pro, showed me, you just do a line instead of a pocketing operation, you do a contour or a profile or whatever the particular program. Because you selected point to point, watch how cool this is. Only SolidCAM has been able to do this. Maybe MasterCam will, because they copy a lot of go here. It's drawn the line for you. We haven't had to draw a sketch, and now you've got the toolpath up there. And you say, oh, you got to go here. There's always some little complication. Say accept it. Now the chain's alive. Now, did we get to name it? Let's call it flat, because you can name the contour and you can name the operation. And it can be handy to do both, just to keep things straight. See, because like here is where if I wanted to use different, if you got holes, different batches of holes. But so far we're so good. Geometry's fine. Little exasperation. They never default to the last tools you used. So you got to go here. We only have one tool, this 1/4" end mill. Say yes. Then, sometime pocket, I think they do multiple step downs and pocketing here in levels. In this one, I think they do it in technology. That can be a little bit confusing, or maybe it was facing. It's not consistent as to where you do step down and step over. To me, those are big important things. I'd like them to be very prominent, but they're not. You can see it's so smart. It's already guessed, well, we're going to start 1/10 of an inch down. And because where that line was selected, those 2 points I selected is down 3, 2, 6, 2, 5. It knows we want to go that deep. So that's pretty cool. Left, I didn't see where the arrow was. Well, we're going to have to figure out if I'm doing climb or conventional. This is one of the reasons I don't like the way it works, but that's life. Left, I think left is climb milling if everything, if it ends up, this path ends up not carving up the model. So that's okay. Where else do you go? Rough. This is where you go down in multiple steps. We're going down 1/8 of an inch at a time. That's enough. Then everybody's got their own jargon. I'd like step over or multiple passes, but they've decided to call it clear offset. And the step over, let's do that same 125. Now they're using language machinists understand. Offset, well, it gives you a selection box. And I thought it would be cool. Well, do I select this line? Well, I want to do this whole flat, so let's try this line. And you see it puts stuff here, which might be good. Turns out it doesn't work as well as I'd hoped. It guesses 0.94, whatever. That's that distance. All this other stuff I think is okay. Link is just in and out. I think we're ready to go. And now I'll pull it up here, and you can see. So you see the toolpath forming, and you got to remember, nothing's labeled. third box over is save and calculate with all related operations. And I feel that's probably safer than just save and calculate. So I've been hitting this one. It thinks, there they are. Down, down, then the last one can't be as much because it just doesn't multiple out. It's doing an extra one here, right? Because if it does this toolpath, it's going to get that edge. So that's where I was like, well, smart as it is, wasn't smart enough. And you see, it doesn't matter. A prototype person like me, I could care less. Do an extra toolpath, right? That's 10 seconds. If you're making 100 of these, you want to optimize everything. I think what worked out good is if I said 0.8 and we go do our thing again and it thinks. And now, yes, you see it's just doing this last toolpath to get that edge. If you don't do that, you will have a little left over. So that's cool. This is where the simulator is down here, unlabeled. The simple simulator, like kind of like that toolpath cartoon that SolidCAM does. Go here. There it is. It's doing its thing. I got it slowed way down. We can speed it up a little. And that's cool. So we love it, right? Oh, we got to name this. See, it picked up flat from the contour name, but it still wants the F. I don't know why the F got in there. What's that for? And say save. Now it's labeled. I noticed that F went in the perimeter too. You can't just pause, click on it, hold to click on it like Visual Mill lets you change all the names. You got to invoke it, open it up, come up here, minor annoyance, but an annoyance. I don't know. Perimeter, save and exit. Hope you can see that. And so now we've got good names. So there's some love there though. The fact that you don't have to make a sketch. Unfortunately, they do clutter up your toolpath with this business, which is the stock box. So I could set this point up here. We'll try it at the end. I think you can erase this whole thing off of your part tree. And since you've already done the one thing you needed, which is locate this part 0 on the stock, what I need, the way I like to work, I think you can get away with cleaning up your tree by erasing this. I think. We'll find out. Hopefully I'll remember. So back here, what are we doing now? We want to do these slots. Now, I used to take a ball mill. Okay, let's make a 1/4 inch ball mill and let's raster across this and leave a little cusp in the bottom. And most of the programs would leave a little meat here, and I had to either, how did it work? Different programs, different things to fool it into one. I made a big entry and exit. I think that might have been SolidWorks CAM by CAMWorks. Another one with BobCAD, you just tell it 3D extents and it knows. It goes all the way down and all the way over. Others I had to do kludge. This one's kind of like SolidCAM. It wants to do the right thing from the very beginning. It's going to do everything it can to make that surface. And it does a great job. Let's see. Right click. Get your milling operations. Now here's a little of the exasperation. Huh? What? Apparently we're supposed to know HSS is high-speed surfacing. Who knows, right? HSR, high-speed roughing. So far our theory as to what their super secret acronyms where they got plenty of room to write it out, but let's be jargon crazy because that's software engineers. So here it gives you a different dialog box, probably because they're using the ModuleWorks kernel to make all these toolpaths, certainly the 3D ones. So it works a little different. Now they want, the first thing you get to choose is a coordinate system. We're in the right coordinate system. We're on top. We like that. Geometry, once again, the mystery button, but you've been doing it, right? If you use this program every day, you're sweet. What worries me is if I use it once a month, because I'm an intermittent prototype user, will I remember what all the unlabeled buttons and slightly different things in every dialog? So here we go. Geometry. I think it was as simple as bang, bang. It doesn't give you the blue SolidWorks kind of selection, but down here it says phase 1, phase 2. Name. Here's a good place. Slopes, plural. I like doing it that way. So now we got that going on. Up here, it's letting you choose different kinds of 3D operations. Parallel to surface. BobCAD does this. Visual Mill has a nice visual, because that must be their thinking. Little icons to kind of help. Oh, okay, that's going to go this way. This one's going to go that way. All right, you can learn all this. This isn't the end of the world. Geometry tool. Once again, you got to select it every time, but it's 2 clicks, but those clicks add up. Levels. Is this thing smart enough? I thought it knew, yeah, it knows what it's doing because it's got that surface. This is what's beautiful. Parameters, we're going to leave it coarse. Down here is the step over. Using language I understand. Step over, good. Not clear offset or whatever it was in the other one. 50,000 is pretty rough, but let's just take a look at it. That's what I've been doing in the other programs. You say here, third button over is save and calculate with related operations. It thinks, and look at these beauties, right? First off, unlike some programs, it goes all the way down to the surface here. So it's doing everything it can to make this surface complete. With Visual Mill, it stops when the center of the tool gets above this point here. And that's a real problem. It's, you make sketches in SolidWorks and you can fool it. The other thing they do, and Mastercam's the same way, they do the whole surface. They're not pulling the tool up a little quick like the other programs where it leaves a little meat over here. So they're going into air. You can just barely see it, I guess, there. The goofiness, these programs are always going to have some goofiness. They're retracting when we get off into the air here, and their truncated paths goes all the way up to here. And you can go, and there's some place to shorten that out, but it's kind of goofy. And why it treats these as separate tool paths, I guess because it's floating in air, I'm not sure. But it does what you want. Let's do a quick simulate. Can you see that? It's hidden behind my headshot maybe. Here, simulate. It's a little too fast. Let's do it again. See, this was what Dave, my friend who made this part to confound CAM programs, taught me when he took pity on me when I was trying to suffer through Mastercam, which to me is the hardest. This one has some issues, but it makes more sense. I think the design overall is better if they just label buttons and do some other stuff. Certainly if you use it every day, this thing is champion stuff. So there you go. And it's like pretty darn close, right? It leaves little scallops because we're doing 50 thousandths apart. So like in the other programs, what I do is here, instead of 50, I go 10 thousandths. Regenerate it again. You won't be able to see it. But if I move it off, now look at that. And of course, with all these extra ones, it's going to pull up. And because that annoys me that for some reason they do it like this, let's just, I told you the last show, I never click up here because I've been burned where, oh, well, you just closed it. You didn't save it. So even though it should be saved and done and ready to get out of the dialog box, and I love that they leave the dialog box up. So you can mess with stuff and fiddle and simulate, whereas Visual Mill, poof, as soon as you change anything, you say generate. I think Bobcat works like that, not sure. Oh, obviously we didn't name it right. Double click it again. Here. I don't know why it added that. I don't know. Here, let's go save. See if it slopes. Okay, so now we got stuff named the way we want. Now, I don't think I've shown it yet. The fantastic simulator that I just adore. Go here, instead of the simulate we've been doing, you can invoke it from out here. You don't have to be in that toolpath dialog. SolidCAM simulator, it's in beta. Note that. So here it is. Now, I found out these artifacts that I noted where you can kind of see through it, and it's given a stock condition, right? So everything's done, everything's green, which means it's within 1,000th of an inch. I found out FX isn't compared. Those are two separate things. This is set stuff yourself. I don't know which is which. The line through it means it's not function in terms of X. But this is, I guess, where you can set stuff and unset stuff. This is the actual compare. They didn't bother to label it because they don't label anything in this program. So with compare off, there's just the stock. I found out what's doing well, let's run it first, just so you can appreciate the magnificence. Here it is. It's doing its thing. And this is magnificent because my buddy Dave showed me, no, you don't just do a ball mill. You leave it. And you're getting, look how it's green, right? Now it's, I could have shortened these big red things up to where it's raising up to the clearance plane or the tool start plane or the plane. That's like Mastercam's got all those concepts. Other programs just leave it buried down there. I think Bobcat did a great job. It's just like, no, we're down there. We're staying down there. We're going to clear it all off. Then we're done. 3D extents. Fantastic. And that is an extra cost. I'm not sure if this is included in the normal 2.5D SolidCAM. I think it might be. You get a lot of power. What 3D to them means is iMachining 3D. And that's a big deal where it's adaptive tool paths and no hard corners in the tool paths, all swoopy. But you notice it's within 1,000th of an inch everywhere now, right? That was my buddy's genius. No, use the ball mill. come down on it instead of going across like I was trying to do. Now these artifacts I found, if you go here, and I believe it is target FST. No, not sure what that means. Now those artifacts, because the stuff isn't transparent anymore, go away, but also the green goes away. So, well, wait a minute. The sides used to be green. I used to be confident. This was green. I was confident. This is, oh, I still can't get it to light up. So, and this is in beta. They tell you when you invoke it, it's in beta. So, okay, good enough. We'll go back to target FF, whatever, Control T, and put it up because now I like seeing green. That makes me happy. The purple, of course, is the extra stock in the holes that we haven't drilled and tapped. We'll do that from the underside. So that's that. Happy. I think I'll do a save, even though there's no choice, by the way, because we've got that CAM thing running. If I go up here and close this, it's going to save all this stuff, update the file date. So why fight City Hall? As always, it moves the tree over, so you got to either use your Logitech mouse with the rocker on the scroll wheel that goes left and right scroll, or do this, or if it's like this, like SolidCAM, I had to do this. SolidCAM doesn't put the scroll wheels down, scroll bar down here. So that's normal. Now I'm learning. The first 52 times I did this, oh, okay, I want to do the bottom now. So let's do a new coordinate system manager. Some of the clutter in those dialog boxes, you know, they don't do that to be cruel. They're thinking, well, let's see, I want to face the bottom now, okay? So you say face. This is why they clutter with this coordinate system. I want to face the bottom. They're thinking, well, you're rocking, man. You're making toolpaths. So now you can go coord sys. It gets you in this goofy thing. You want to add one, new coordinate sys. For me, I want to set it upside down in the vise like this. And I'm pretty sure, I never asked my machinist buddy, you can't reference the top of the stock like I did to start this part, because then the height of the stock will affect how big the part is, right? All it would know is I go down from the top of the stock. It wouldn't know where it was relative to the part. So I am pretty confident I have to put the stock, can't put it up here because there is a big slab of stock above this thing. I figure put it down here, and that I can find on the parallel. Hopefully X and Y will be the same, and all I got to do is find Z down on the parallel where I'm going to set this part. Life is good. Select face. This is more exasperation, right? This is what tripped me up so much at the beginning, the first show. You got to know, okay, it wants you to select something because the origin is going to be down here. I learned if you select the top, you know, the face is, the plane is going to be wherever you select the origin. Now it lets you select an origin. It's giving you this box, right, with the little asterisk, so you can put an origin there and there. We want to go right here. It defaults to the world coordinate system, not to be confused with the WCS work coordinate system in SolidCAM. And then, like all these programs have an easy way, let's think of what we got to do. Z's got to point up now because we flipped it in the vise. So let's flip around X twice, once, twice. Now we've got a flip around. Z is in the right direction, so that's what you flip around once, twice. And now for my Avid Benchtop Pro, this great little router style mill. It's very stiff for a router because first off, it's small and it's built really solidly. And so cutting aluminum, no problem. Some people cut steel. So we got that. And now because of the way I'm going to set this in the vise, and the way the vise is in my particular machine, positive X is to the right, positive Y is to the back, Z is up. Life is good. I think we're all set here. Did we give it a name? I don't know if we can name it. No, that's right as we leave. This is where I got all screwed up because it's going to complain again with these goofy, you know, hey, upper sys is below lower sys level coord, blah. This is a data structure. It's not just a coordinate system, plane and a point and an orientation. It's got all this to help you. Well, where's the tool? Where's the part relative to this plane? What clearance level? How tool start level? 6. That's where that red thing was going way up in the last operation. I don't feel comfortable changing this. They're smart people. And everything is, of course, geared to being safe and not breaking a tool or hitting a clamp. So let's just leave this. Say yes. It gives us this last goodbye dialog box. It's thinking, it's labeling. And here is where you can select it and say bottom setup. You know me, I like labeling stuff. And you don't say, okay, add what I just wrote. No, you just go up here and say, okay. And Mac, I'm not sure, machine, address coordinate, I don't know. So now we've created that coordinate system and we've selected it, and because I like renaming stuff, we know this is the bottom, this is where we're supposed to be. And like when we did the face in the first episode impression, you don't select anything. If you select just the face, it would treat it like a pocket and wouldn't do the stock out to the edges. So by not selecting anything, that's this mystery button, a stock-based boundary. So it'll know to clear the whole thing. Tool, same minor exasperation. You say select. It's only 2 clicks, but Visual Mill just defaults. Last tool you used. Levels. Look how smart it is. It knows the stock starts 1.4 up, and it knows the face depth it's going 0.4 down. This is going to do step downs of 125 because that just inherits. It always remembers what you want it, don't want it to remember to, and it defaults to some standard thing when you don't. That's normal programming. I'd rather go down to 10th because it's 4/10. Let's take 4 passes. They'll all be equal size, equal chip loads. Set the speed once with the controller. You can bump the feeds and speeds and spindle speeds up. And once it's doing good on one level, it's taking the exact same chips on all 4 levels. So that's why I changed this. I think it's ready to go. Technology. Oh no, this is wrong. Hatch. I want to do a contour. I hope this is going to work out right because I don't understand. It says climb. Let's hope that's all cool. See, that was my thing about it. Always defaults. I set it to contour, but it likes going back. Tool diameter, half of the tool diameter. Okay. Link is entry and exit. I think we're okay there. All this other stuff, I got a long time before I'll get to that. I'm just happy to get started. Let's pull it off to the side so we can watch the tool paths. Come up here. I think you can just barely see. Save and calculate with related operations. See, now this is that same nag we got on the top face. Upper level is above coord sys upper level. And there is no such thing as a coord sys upper level. There is a coord sys part upper level. And the upper level of what? I assume they mean the upper level of this cutting operation. Okay, fine. And what that would be, I assume, is the lead-in. Not the tool, not the red as it comes down, but then it slows down as it gets above it. I think maybe that little piece, I've tried to fix it. I think it's probably safe to turn this, don't ask again, but you're never sure. Let's say yes, see what happens. There we are. How cool is this? Oh, and now it's doing what I wanted. It acts more like Visual Mill, where it goes around in circles, climb mill and the whole thing, which is going to be kind of important here, because when you climb mill around these edges in this, it's not circular, in this rectangular thing, as opposed to just doing straight wax, the climb milling kind of pushes the burr into the part and doesn't leave a jagged edge. And we were smart about the perimeter we did in show 2 or whatever, where we went under a little bit. So this top perimeter for these sides, you're holding in the vise on the part right now. All this should be hunky-dory. We'll click simulate. Not much to see here. Speed it up. Speed it up. We're right on schedule, baby. Because next we're going to do a whole show about the holes. Do this one. There we are, right? Happy. Close this. Get the dialog box so you folks can see it. I have 4 monitors, so it's pulling this stuff on and off. It's not an inconvenience. It's actually, they're doing great for me by opening stuff off screen so it doesn't interfere. I think we're okay. Do our save and exit. Once again, it nags you. Like I said, probably can get rid of it and turn the toolpath off. You can, it's stock aware. So when you say simulate here, our favorite simulator, it's now flipped upside down. It's got all green everywhere. It's got these artifacts, which are a bit of a pain. You say, do your thing. It's a little extra slow here. Speed up a little bit. I'm not sure what artifact. Yeah, see, the artifacts make it a little rough to see. But oh, you don't have to have compare on, right? What am I doing? So do that. There it is, right? And now turn on compare, and how happy can you be, right? It's got those artifacts, but that's better than, and I'm not sure if this is a problem or something that they had wrong. Target FST. Okay, the artifacts go away and the part turns more opaque, but the green goes away along with it. Probably rounding errors in their calculations. So I prefer to live with the artifacts. And where were we? Target FST. especially now that there is no stock hanging on, right? Green everywhere. Green in the corners, green where we went from a deep pocket to a heavy pocket. This is some happy days. And so next, do the 5 holes. And like always, like SolidWorks CAM by CAMWorks, the automatic feature recognition, it wants to do 2 from the top. It wants to do these 2 on the top, and then do these 3 on the bottom. And I think it splits those up, whether they're blind or, and you get all these tool paths and all these tool changes. So I think I tried automatic. I'll practice for you folks so you don't have to watch me stumble around. But like usually, it's easier just to do them individually. And then we can use that save as a copy if we want to save the 5 hole locations, right? But that's so easy. So there you are. We got, 3 tool paths today? So that's a good day. We got a new setup on the bottom. We're getting more comfortable. Like I say, if I use this program every day, if I was a CAM programmer at a machine shop, 7 hours, 8 hours a day, 7 days a week, this would not be as exasperating. Oh, how did I do that? What did I do that? As it is, as an intermittent user, I'm a little worried. Will I remember all these things a week from now or a month from now? But bless their hearts, I love SolidCAM as a company. You deal directly with them, no value-added reseller, and they gave me a 60-day trial. This is a full-blown, it'll post code, it'll do anything you want. So I'll have time, and when we get done with this, I think I'm going to look at all 5 packages. How do they deal with a fixture? If I have a flat plate and 2 clamps holding it down, that's something I'm curious about, right? Do I make an assembly? There's different ways to deal with it. Do I make an assembly and then open it as an assembly? How do I work all those things for fixturing? So there you go. Hope you enjoy it. Hope your CAM projects are fun. Sportster Paul here. Catch you in a bit.